Hot chocolate, red off well.
Azure, Cosmos,
Dapper.
Entity framework, power tools.
Netforgy suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shay Rojansky.
Grace Lampson.
Arthur Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
All right, we are go. Welcome to another .NET Data Community Stand-Up. Very excited to be here today with Mr. Shay Rojansky. And we have Jon Smith in the house. We are going to be continuing our conversation about testing. Before we do that, we always kick off with a State of the Unicorn. And I did my best to cobble this together because unfortunately Arthur is out. Actually, fortunately for him, I believe he's out somewhere thinking blissful thoughts. So this is my stand-in for Arthur. And I know that his cats are kind of a thing. I don't have a cat. I have a German Shepherd. So I took care of the cats too. So hopefully that'll satisfy some of the cat curiosity. But what is going on with the .NET Data team? We had a preview 4 release. You can read all about that in the blog post. You may recognize the author. I know him quite well. And we cover some of the updates there. We have a few big features that we're building on that I'll talk about in a second. But I also wanted to just bring up this GitHub issue. So we are working on a new landing page that we're calling the .NET Data Hub. Now, the idea here is to have a page that gives you one-click access to .NET resources related to data, everything from big data, ML.NET, SQL Server, EF Core, and this issue kind of tackles that. So if you have some feedback, insights, recommendations, please take a look at that issue. So on our daily builds and what you'll be able or be receiving in Preview 5, we have table per concrete type complete. I think there's one issue remaining, some minor thing. The majority of the update pipeline, this is something that Shay came on and talked about with our update performance enhancements, is complete. I think there's maybe some small items, or are you pretty much shifting gears?
Yeah, I'm done with that part for now. I might come back and do small stuff later, but we'll have some exciting things in Preview 5, especially, some of it in Preview 4, and I'll be doing a blog post at some point.
Very good. We are continuing the work for database scaffolding. So if you're not familiar with that, you can actually use T4 templates to customize the scaffolding of your DB context. So we want to give you a default template that you can start from. So that work is ongoing, as well as the work for JSON columns. So having said all of that, wait a second, what's going on here? I
here.
believe we have an
Yay!
Arthur sighting. What's
Can't
going on,
help you
Arthur?
with can't help you with the cats there. They're still at home, but I'm in beautiful Santorini, live streaming. This is live. This isn't a background. I don't know how to
Wow.
prove that. Like maybe cruise ship will actually like move or something, and then
You can
you'll
do that
see
with fake backgrounds, though.
what. Right, so you don't
Yeah.
think I'm here? Like I don't know.
I don't know.
But-
I have my doubts. It looks too nice. It looks.
okay, if I had something, I could. Okay, here we go. Can you do this with fake back? There you go.
Oh,
It's real.
very good.
Wait, I don't
I've got
think
my
that person
I've got my hot
appreciated.
tub over to the right, and I've got the sun setting here, and the camera can't deal with the total amount of light that's supposed to be in a dark basement somewhere. So, but yeah, no, I'm here. I always enjoy these things, so I figured I'd just pop in and let you guys continue and probably interject a few things about testing or whatever as we go along. So,
Sounds
ever.
good. Well,
Yes,
I'm going
as
to
ever.
step back and turn it over to Shay and Jon to talk about testing then, and I'm going to bask in Arthur's glow from his tropical paradise. That's awesome.
So, yeah, I'll start off. We did a stand-up in January, and we talked a lot about testing and our what would we do and things that we've done, and there was lots of theory, and it was great, but we wanted to get to some of the code. So I'm going to give you a quick. You should, if you haven't seen that stand up yet, I'm going to give you a quick intro to what we're looking about. So here is we're talking about automated tests, and this is a very, very simple automated test. I'm using XUnit, which is what EF Core uses, and lots of other things use, and it's very, very good. And if you get in that a new get for XUnit, you will get a attribute called fac, and if you put it on a method with a certain signature, it will run that. You can. There's a test runners in Visual Studio and Visual Code and .NET and all that sort of stuff, and it will run that and test it. And this is a kind of pattern that everybody uses. There's a bit where you set up things at the beginning. You might need to put some things in a database for our stuff. Then you run your bit of code that you want to test, and then you check that it gives you the answer that you expect. So that's just a super quick overview.
You could use NUnit or anything else for this as well. It doesn't have to be XUnit. Just some kind of simple. There was originally a JUnit. JUnit was the thing that was produced for Java around test-driven development, and it was actually came from some Smalltalk tools that they had before that. But the idea is just put together little snippets of code, and then you can run those little snippets of code rather than having to have an application. So I've always wanted to ask Brad Wilson, who was one of the authors of XUnit, why he chose to call them fact instead of tests, like every other NUnit, XUnit, JUnit like framework, and you just put test on it, you say that's a test. But apparently in XUnit it's a fact, so go figure.
But if you have multiple parameters, it becomes a theory. So,
yes, I know, that's awesome, isn't it? But
Yeah.
it's a little confusing at first, I think. It was like, what do you mean fact? No, this is my test. This is a fact about my code, I guess. Anyway,
I'll be talking about XUnit. I think it is one of the best. I've used NUnit a lot, before, but XUnit I think is very good, and I know you guys use it. So that's
we
it.
did an analysis like 10 years ago between NUnit and XUnit and decided on XUnit. But that was like 10 years ago. So who knows what it will come out with now. But yeah.
So another thing, this was from the first stand-up. And we talked in quite a lot of detail about the 3 different ways that you could test your EF Core code. And the gold standard is using the same database type as your production. And that's that. This one was about SQL using an in-memory, and I use SQLite, not the in-memory provider. It's much better, and the team say that as well. And this stubbing, lots of different names for that. I'm not going to go into that again because we covered it before, because I want to give you some code, because if you're using if you want to do EF Core testing, automated testing, you've got to watch out for a few things. So I'm going to move on. Shay, anything to add?
Not really. So yeah, I will add just a few words. So I really do recommend everybody who did not watch our previous stand-up to go and watch it, because there's this thing that you see here on your screen is actually, these 3 points are very important to understand exactly what they mean. There's various approaches to what, how you're going to test. Do you actually involve the production test, which, as John said, is what we consider to be usually the best thing to do. If you do want to remove your production database system from your testing, you should know why exactly you're doing it, and it means that your tests will be problematic in various ways. Anyway, there's a lot of, because I don't want to reproduce the whole discussion from last time.
No.
There's a lot of pros and cons each way, and it's very important that you guys understand it. But the important point here is that this time, what John is going to be speaking about is that left column. So we're not going to be talking about, we're not going to be talking about mocking the database, mocking EF Core, all that kind of stuff. That's not the subject of today's stand-up, although you can do it. We're going to be talking about techniques for, what do you do when you do want to test against your production database, just to make that point clear.
Okay. So I came to, well, we talked a lot about our experiences of using automating testing, and I love it. But I love the feedback, but I still want it to be quick to create, quick to run, and easy to understand. That's that. And I wanted to say to you, if you've never written unit tests before, I was trying to think. I've definitely written more than 1,000 tests, automated tests. I don't know how many, over about 20 projects, right? And
I think we have about 90,000 tests that we run on every build of EF Core at the moment. So,
which again, it's important. I'll add again. So some people shy away, don't want to go into testing against the real database because they think it's going to be slow, right, and unreliable. EF Core itself does the bulk of its verification, of its automated testing, which Arthur just referred to. The bulk of that is actually against real databases. So we run against actual SQL Server, actual Postgres, actual Cosmos emulator, actual SQLite, and that works really, really well. And we believe
takes
that's
about 5 minutes on a fast laptop to run them all. So it's not slow.
It is. Yeah. So again, there's some challenges when you want to have a huge comprehensive test suite against a real database. There's some things you have to watch out, and that's exactly the focus of our session today. But it is very much possible and very much worth it in our personal opinions, I'd say, in the team.
Yeah. I just wanted to say to you that you won't, if you've not done any automated testing before, you'll find it really you're kind of, it's taking too long. I'm not sure I'm doing it the right way. It'll take a while to get a pattern. You're used to creating methods and using ifs and all that sort of stuff. You're just going to have to establish a pattern, and it takes a while to get that right. So just be aware of that.
100% agree.
Yep.
So this is what I wanted to get to. We didn't get to last time. If you're going to test EF core and you're going to use X unit, there are 4 things that you definitely need to do. And I'm not going to read that out. I'm going to go through each one in turn, right? But if you don't get these right, you can get into trouble. So let's have a look at this first. So X unit runs each class that contains tests in parallel. That is fantastic. I can tell you. It's I want this quick, and I can run stuff that are really quick because it runs in parallel. But if they're going to be running in parallel, right, you need a unique database for each test class, right? Otherwise, you can't have them all parallel go to one database. You could I could do that when I was using NUnit because it's serial, but you can't if you're using XUnit.
So there is a way to make an XUnit class run in serial. Just wanted to point that out.
Yeah.
You
Sorry.
can.
Yeah, there is. Yeah. And there's a setting on XUnit that will make all of them go.
Yeah.
So this. Go ahead.
So I was going to pass on to EF core people because they have one thing they use for where they have a database with a lock on it. And Shay, do you want to?
Yeah, so I'll preface this. I think maybe Arthur also wanted to say something about this. So this idea that test parallelization is an awesome thing, as Jon said. It was introduced, by the way, not so long ago. I remember I was doing testing 10 years ago. Test frameworks were not parallelizing. This is something that came in relatively recently, and it's a revolution, but it forces you to think about what happens when your tests run in parallel. And the big problem is to avoid interference, to have each test run in its own isolated box and not have them interfering. When you're doing stuff on a database, so I would put a little bit of nuance into this. So it is actually completely fine for multiple tests to access the same database. You don't need to worry about separating them as long as, for example, the tests are read-only, right? What I'm saying now is pretty obvious. But if all your tests are doing is running queries against the database, then you can run as many of them as you want against the same database across all your fixtures and everything, and it's going to be fine because they're read-only. And in fact, even if your tests are not read-only, if they're modifying the database, usually the typical thing that you do is you're going to run those tests and their modifications in a transaction, and you're going to roll back that transaction at the end of the test. So you're not actually committing any changes to the database, which once again makes it safe and isolated. So you can run tests in parallel once again. And I'd like to show how some tips on doing this. So the cases where you really need to prevent tests from running in parallel are actually quite few in my experience, namely when the tests themselves have to drive transactional logic. If they have to start and commit transactions, then they actually commit to the database, and that's where your interference and the isolation kind of happens. So I tend to, in my mind, split tests into 3 categories. One category is tests which are completely read-only, no problem there. The second category is tests which modify, and there you can use transactions to roll back at the end. And again, you don't have any problem with parallelization. And the third category, which is the tricky one, is tests which do transactionality themselves. And there you have to do some extra things. You have to avoid parallelization. You have to clean up the changes at the end of the test and reseed the database. Everything is more complicated. So that's just a little preface I wanted to say. I'm sorry if I'm rambling a little bit.
Let me add a little bit to that. So this is great that we're talking about databases because it's a very concrete example, but this isn't really about databases, and I think that's something that is important to think about. This is about mutable states, specifically things that one test changes where another test can observe those changes, can see them happening. So obviously, if two databases using the same test, and one thing saves a record into that database, then another test running and using the same database can see that. And so then you look, okay, well, I was expecting to get 5 records back, but I got 6, for example. So that's how data. But this also happens, for example, if you've got global state in your application. So if you have a public static something like a singleton that's available to all of your application state, and one test does something with it and another test observes that, then when you run them in parallel, you're going to get varied behavior, unpredictable behavior, depending on which one does it first and whether they overlap and all of that kind of thing. And that's why really you should try in your test to make sure that you don't share state between tests as much as possible, or specifically you don't have tests that are able to see the changes that other things made. And that's why you do things like create a different service provider if you're using DI, because creating a different service provider can allow one test to have one service provider, another test to have another service provider, and therefore they don't see the state changes in services within that, for example. And there's other things like that. And this actually, quite often databases is one problem with this, but actually, things like, for example, when you're trying to test performance counters, you have another issue with this, because performance counters generally are observable by everybody, right? There's something sets a performance counter to, and then other things test it. And if you're trying to test that it's counting the right thing, that can be really problematic. And we had an issue where I was trying to test some perf counter stuff last year or something, and I came up with this complex design to make it work, and the people on the team said, don't do that, let's just run these ones in series, let's just not run them in parallel. And it's amazing that sometimes you just got to step back and say, if I'm getting into so much complex stuff with the parallelization, take these specific tests and say, just run those in series, and then XUnit will basically run everything in parallel, except it'll take these ones and it'll just run them at the end in series. And so always, take a step back and think, if I'm doing something really complicated here for only one test to try and test something weird, that's not normal, you might want to just run it in series instead. So I just wanted to add that as kind of a wider context around this. But database is a really good example of this, especially when you're doing EF testing, obviously.
Right.
Do you want to see? I was going to show. Oh no. Oh. Hang. Yeah, you have. This is EF Core's documentation. And they show how to have this. This is with a fixture, yeah.
Mm-hmm. Mm-hmm. Do you want me to talk to this a little bit? So, yeah. Okay. So as we just said, so it's fine usually to share a database as long as tests are read-only or read-write, as long as they don't do transactions. So we said this, but you still need to create the database, and you cannot. If you start, sharing the database between classes and everything in parallel, you still have a problem at the point where you need to create your test database, right? Because you don't want 2 different tests running in parallel to trigger creation of the exact same database. That's going to obviously fail in some way. That's going to race. So what you see here, you know what? Maybe if you guys can switch to my display, because I have that exact code, but a bit more in an IDE. Yeah, there we go. It's exactly the same thing. So what you see here is an XUnit fixture. I don't want to talk too much about XUnit and so on. Let's just say that this is a thing that's going to get injected into multiple test classes which execute in parallel. So this thing could be created in parallel. Now, what you see here is, let's disregard the lock just for a second. When this thing is first created, and again, this fixture can be instantiated multiple times for multiple test classes. What it does is it has this bool, this static flag that says, have I already created this database in this test run, right? And if it did, then we don't need to do anything because we've already created it. But if we haven't created the database, then we're just going to use plain old EF Core code. We're going to Yeah, we're going to use ensure deleted to drop the database if it already exists. Remember, this is the first time that we run this code in a test run. We're going to drop the database because maybe just maybe the database already exists from a previous test run and it has an out-of-date schema, right? Maybe we're iterating over our model in the tests and the database that's left over from last time, it's no longer valid. We can't run on it anymore because the schema has changed. So first thing we're going to do typically is going to drop it, going to make it go away. And we're going to create it with the latest schema. That's how we ensure that the tests are running against the latest version of the database every single time. And then we're going to seed it with a little bit of data because we want to query against it in our tests at some point, right? So we seed it and we save those changes. And at the end, of course, we're going to set database initialized to true so that this thing only happens once. Now, the thing is, because now we're in a parallel world, because of, as we said, parallelized unit testing, this code, this constructor could be invoked multiple times in parallel. So we have a lock here simply around the creation and the seeding of the database. That's the only thing here. It's actually very, very simple. That's the only part in this specific scenario which we don't want to parallelize. Okay, assume that the actual tests can run in parallel, but the creation of the database for those tests we cannot parallelize, because if you do ensure delete and ensure created at the same time concurrently, it's going to be a world of mess, right? So we protect that part with a lock. I hope that part is clear. Of course, there's always the option, which John was alluding to say, no, every test class which has tests in X unit is going to have its own database. And if you go down that route, you don't need to worry about this, because each class runs, it doesn't get parallelized. It gets its fixture once at the beginning, the database gets created, and at the end, whatever, doesn't matter. You don't have to worry about this. But assuming you want to test against the same database, then you do need to worry about this. I'll give one short example inside the if core tests. So we have, again, as Arthur said before, we have a very extensive test suite. But what we do is we have a single Northwind database. Now, anybody who's done Microsoft databases knows about Northwind. It's this fake sample kind of database, which all the Microsoft samples kind of use. It has customers and products and orders and all kinds of fun stuff. What we did early on is we set up this Northwind database. It's created exactly once, and then we have a ton of test cases running against that same database in parallel, performing read-only queries. A ton of those things, okay? All we have to do is make sure that the creation of Northwind is protected from parallelism, so it happens only once. Once that particular initial step is finished, all the tests from, all the parallelization kind of just run against that database and everything works just fine.
Yep.
Okay, so in EF Core, you have got a very structured testing. So for me, I just start writing tests, right? and what I do is, I'm going to show you. I have a way to get a unique database for each test class. Why do I do this? I want I end up with having something that is very isolated from everything else, and I can just think, oh well, I'll just throw this up, do this, da-di-da, and there's no, I don't have to think about all
Keeping
these
it
other
simple.
things. Yeah, I'm keeping it simple. So I have this in my library, which is linked in the bits with the URLs
links,
with this
The show
Standup.
links. Yeah.
Thank you, show links. I had this method which will create the options, and what it does, I'll show you.
I like this.
So I have a connection. I have an app setting JSON in my test project, right? And there is a thing called unit tests connection, and it's got the connection string, and you see it's got a name. So that is the start, and then my go back to this. What it does, it takes because it's got lists, it can get the name of the class, and I put them together, and I get therefore a database which is unique to this project and the class. And if you look here's I've got a library called auth permissions, and I've got test, and look at them. I've got loads and loads of little tests that get created for each of the test classes. And I've got some more for other things. Here's schema compare, test support, so I just get loads of, I create a database for that class. It's easy, it's isolated, I don't have to do anything clever, bang.
One of the questions, sorry, go ahead.
Yeah, so?
One of the questions we often get is, should the test or the fixture, the test class, should it clean up as delete its databases at the end? And I think the reason we get this is because we don't do that in the EF Core test suite. We leave the databases there, and there's a couple of reasons to that. One is that you can have some perf benefits from reusing a database that already exists, but you've got to be careful about that because, as Shay pointed out earlier, it could get out of date. But the main reason to do that is if your test fails and you've deleted the database, then going and figuring out why it failed can be harder than if you've got the database and you can actually look at what it's created, what's in there. So that's one of the reasons we like to leave the database there at the end, and then before we run the test again, make sure that it's in a good state, but leave it there so you can debug what happened when a test fails.
Yeah, my library has some code which will look for any databases starting with the project name, and we'll delete them all. And this project name must have test on the end to stop you from wiping out your
So don't call your production databases with test at the end, is what Jon is telling you.
Do not do that.
Not when you're using his library in any case.
So that's how I do it, it's just it's simple. It's simple because I put the time in to create the library to do it. Yeah. But it's just simple, lovely. The other way you could do it, I know Shay doesn't like this, but obviously if you have a SQL-like in-memory database, it only exists in the method, right? And it gets the using var, it will get thrown away, disposed at the end. So that's another way to work with XUnit.
SQL-like in-memory databases exist as long as there's a connection open to them. As soon as you close the last connection to it, it goes away. So it's easy to clean up.
So just so that everybody is clear, this is the alternative model where you're not testing against your real database, because typically your real application is not going to be using SQLite. I'm making that assumption. It's not always true, of course. But if your real production thing is using SQL Server, and you're using SQL in memory and your SQLite in memory in your tests, then you're using a test double. And then you're in the other world of using, you're not testing against your real database. Specifically, EF queries may get different results because SQL Server is case insensitive and SQLite is case sensitive. So you're going into that world where things will no longer behave as queries will not behave in the same way as they do in your, in your production app. As long as you're aware of it all. Yeah, exactly. I think Jon has the exact slide for this.
Yeah, so I'm not going to, we talked about this a lot in the first thing, first stand up, but you've really got to be careful, particularly anything that is giving you the wrong answer is a very bad thing to do, right?
Yeah.
So you've got to be really careful. But it's one way to get around the database for that is not shared. So let's go on.
This slide is why we usually recommend not going down this route, but rather putting in the work and testing against, say, SQL Server against your production database. We constantly get questions where people say, okay, I'm using SQL Server in production and I want, SQLite in memory to behave the same way like SQL Server.
Use temporal tables. Do temporal tables.
Do temporal tables, or they're using in memory and they want transactions because, or something, or raw SQL, which is, completely impossible, right?
Yeah.
There's absolutely no way. I mean, it's not that we don't want to help you guys out. It just doesn't work. It doesn't make sense. Which is why we say if you want to test with these things, then you should probably look at doing testing against your actual production database, or maybe a repository pattern. But again, that's the other talk which we already did, so we can move on.
So the second thing we've got to worry about is that the database matches EF Core's model, right? So if you are, build incrementally improving your application, you will be adding new properties into the data to the classes that are mapped to the database. You might change some configuration. When that happens, if you've already run the test and you've just left it there, then what will happen is it won't work right? Because the database is, if you just created it with the old configuration and then you change it, it's not right. So you've got to handle that. So there are 3 ways to do this. The classic way is ensure deleted and ensure created. Let me show you some. Here we are. This is the classic way of doing it. You delete the database and then you recreate the database, and that is brilliant. That's going to do it. I am a complete speed performance test thing, and there is a thing I was asking in an issue with the EF Core team about, is there any way I can kind of just take all the tables out and everything? They said, well, deep inside our code, we've got some code that does that, and it does this, does that, but it's too deep. With their permission, I pulled it out, and I use it a lot. I'll show you down here. So ensure clean will delete tables, views, functions, everything, and then call in ensure created to reproduce the database, the right database. I put that in every test, and that's what I use.
I think this brings up an interesting point, which is, when we state that you can use your real database and run all your tests against it and have it be very fast. Now this varies by what kind of database you're using. But for example, if you're using SQL Server, the thing that isn't super fast is dropping and creating databases. To some degree, also the DDL, the creation of tables and that kind of stuff, is also not fast. And so we started off on EF Core just doing ensure created, ensure deleted, and together with using, as Shay had shown earlier, Northwind as a shared database for a lot of the query tests, so the read-only tests. That was sufficient, but then really it became a bottleneck, dropping and creating the databases. And so in the same way as, Jon has done here with Ensure Cream, we came up with a kind of mechanism that works for us, where we avoid dropping and creating the database itself, and we just make sure that the tables and everything are up to date. We haven't made that publicly available as part of EF Core because it has limitations, and we basically have made it work for everything that we need to do that we're testing, but it doesn't necessarily work for everything that everybody's doing. And so this is obviously an advantage that you have if you have a a constrained domain of inputs to something, then you can write code that works with just that constrained domain. But if we make it publicly available, people start using it, and then it doesn't work properly for them because they've got something that we don't support, then it becomes quite difficult for everybody. Customers don't expect that. We don't really want to support it. So I think Jon's ensure clean here is a good way to go to get something that we don't have to support, but will probably work fine for a lot of your cases and will avoid that potential bottleneck. And we're talking here, I say potential bottleneck, but like I said, we've got 90,000 tests running. So, we've got probably, around 100 databases, I would guess, that we create, in this process. So if you've got, 5 or 6 databases, the ensure created, ensure deleted thing is going to be absolutely fine. So you're not going to have issues with it. But once you do get running lots and lots of tests with lots and lots of databases, then that can be a perf bottleneck. Certainly on SQL Server, not so much necessarily on some other platforms.
I'll also add one more thing. There's also the question of when you're going to be doing, this ensure create, ensure dropped, ensure deleted, ensure created. If you're doing this with absolutely every single test, that's a lot. That's a huge amount of overhead, because typically one test does one query. If you're actually dropping and creating a database for every single query you're testing, that's a huge amount, and usually is also not necessary. So in many cases, you're going to move that setup code to happen once per class. So you're going to put it in what is called the fixture in XUnit. That's the kind of code that. So what you see here before you in Jon's example might be necessary. It's happening within the context of a single test. If you actually do have ensure clean or even ensure deleted created in every single test, yes, that might be extremely slow. However, if you know you're safe, and once again, for example, that your tests are read only and so on, you can move it to happen once for all the tests in that class, and then the overhead is dwarfed, and then maybe it doesn't matter so much anymore if you're going to be doing deleted and created every time or clean. At that point, maybe the difference isn't necessarily important anymore. But as in all things, your mileage may vary, right? So all I'm trying to say is basically pay attention to exactly when you want to create your test databases and what you want to do with them afterwards. Do you want to are they being changed? So do you need to clean them between every single test, because the tests are transactional, and so they actually have to commit changes, and so you need to clean them up? Or if you're not actually committing anything to them, then there's no need to recreate them between tests. You can do it just once, right? So always pay attention to these questions.
So this is where my philosophy and yours, we differ. Every test is completely encapsulated. It's you could take it out and put it somewhere else, and it doesn't really it's so every one of my tests will have ensure clean, right?
Mm-hmm.
It just will, and I've got this. I ran a test, but you couldn't see this because it wasn't big enough. But this is one of my libraries, 305 tests, 301 run, and it says it's 1.6 minutes, but it actually takes about 5 seconds, right? And some of those are SQLite in memory. But I like this separation, which makes it completely isolated. There it is. I put it up. I clear the database. I put my data in, and I run it. Right. So that's my approach.
It's an interesting question, and I fully recognize what you're saying. Right. It is two different approaches, and I know. Yep. I know some people do like to have their test completely self-contained without any sort of dependency on invisible things happening behind the scenes.
So
Go ahead, Arthur. Sorry.
Well, I was just going to say, I think there's a principle of test isolation here, right? That's like kind of creeping under the covers. And whenever there's a principle, or usually when there's a principle, it kind of comes up against pragmatism at some point as well, right? And so, more generally, test isolation is the idea that every test is completely isolated from every other test. So you can run any test and it will never see any state that has, been set up or changed by any other test. It will always be completely the same. Now, if you think about this from a database perspective, you could say, well, that should mean, like Jon is saying, that it always creates the database. Like, it never relies on some other test or even the fixture having created a database, right? It's always completely isolated. But from a pragmatic perspective, I think it's worth also remembering, and this is my number one thing when testing, think about what it is you're testing, right? Because people, for example, another case of this, which isn't databases, is, again, I'm going to go to the DI service provider, where basically you say, okay, well, I'm going to create a completely new service provider, and I want all of EF to have all of its caches and everything completely reset. Like, I don't want the query cache to have a query in it, because I want to make sure that my test is running isolated and is not using a cache query that some other test is. And it's like, but why? Why do you want to do that? Is it because you're testing EF? Are you testing that EF's query cache works correctly? If you're doing that, then that makes sense to isolate that. But if you're testing your application works, at some point you have to say, I'm going to assume that EF is going to do the right thing here. And so I'm going to assume when it's caching services, when it's caching queries, when it's caching the model that it creates and everything, that's okay. And I don't need to isolate that like between my individual tests. And some people will argue with that, but you can go deeper on this. You can say, well, are you going to restart your machine before every test, because the machine has safe state in it? And so if some test is run, then that particular piece of disk space may have been cached into RAM from the operating system, right? So you're going to do that. Are you going to rebuild your machine? Are you going to buy a new are you going to recreate the universe for every test? So there's a pragmatic thing there, and I think the important thing is, my battery's running low, I might have to plug in. The important thing to remember on all of these things is, what am I testing? Like, have I isolated what I'm testing in my code from the other things? And that may mean that sharing a database or not recreating the database every time is okay. But to Jon's point, keeping it simple,
Yeah. And
if
what
you don't
I
have to think about that too much, then that's good.
what I like about what I like, as Arthur is plugging in, what I like about what Jon here is advocating is that you also don't have to think whether your tests are modifying the database or they're transactional or they're not. You just have your own database for your test, and it's always going to work. And if for example, you started out and the test was read-only, so you made that assumption, and suddenly some developer 1 year later comes in and adds some other thing, then that's going to break, right? In my model, or in what I was saying. Whereas what Jon is basically saying, if you have your dedicated database and you're sure you're cleaning it every single time, then you have less risk. That's true. I will just say, one last example for this, like one thing that comes to mind, if as part of your seeding, for example, if the seeding happens to be seeding a lot of data, I'm just giving an example here, like a large binary data, and the seeding itself starts taking a lot of time because for some reason you need a lot of data for your tests, then for example, that's introducing slowness into every test that you might want to avoid by using a fixture, right? That would be like a counter example.
I do that, yeah.
But I fully get, Jon, your point as well, and both.
I
both
would
approaches.
say the difference is you're much more thought through what you do. I just write tests,
But that's
Yeah.
the way you should do it, right? I mean, this is premature optimization to perfect example of premature optimization. Trying to think too hard about I'm not going to use my production database because it's too slow. That's a premature optimization right there. So like, use it. If it gets to the point where you've got tests that are too slow, figure out, I'm just going to recreate my database each test because I know it's going to be clean. I know the state's going to be good. I don't have to think about it. That's great. If that becomes too slow, then go and optimize that. It's don't try and figure it all out up front, or you end up doing loads of stuff you don't need.
Yeah, I like
we've
this,
got to, and we've got to, like I said before, we've got to these places because we have analyzed when our tests are getting slow, where's the bottlenecks, and fix them. It's like you may run into different things, but these are the things that we've run into, and so it's worth pointing out for that. But we're testing EF as well, which is another important thing. We are not testing an application using EF. That's why the in-memory database is really useful to us, because in a lot of cases, we don't care what's happening in the database. We care what's happening in EF. That's what we're testing. Doesn't matter what the database does. What matters is what state gets set in the change tracker or whatever. And so for us, the in-memory database is fine because it's not what we're testing. When you're testing an application and the stuff that gets stored in the database and the queries that it runs again are a fundamental part of what you're trying to test, then it's not fine anymore.
Yeah. I'll just quickly, where are we? Yeah. So, these are the times of ensure delete, ensure created, and ensure clean. It used to be very slow on the SQL Server, but it's now 1.5 seconds. Ensure clean is half that. Postgres is like blindingly fast, and SQL in memory is just nothing, right? So so we've covered that, and there's pros and cons. I have lots of different projects, so what I do is most likely different to your mammoth project.
So just before we move on from that, there's some questions about local DB or not, and I think we'll just cover them quickly now since they're coming up. Should you use local DB? Should you just use SQL Server running on your machine, or maybe on a VM? I think most people on the team, we've stopped using local DB. Basically, we support it. It's a bit flaky, to be honest. I think it's probably, my suspicion is because it used the namespace provider, which is itself a bit flaky, and obviously nobody uses in production. And so I generally just have SQL Server Developer Edition running on my machine. You can run that on Linux, you can run it on Windows, it's fine. Or you could have it in a container. That's another way of doing it. I personally wouldn't put it on another VM because you're gonna have latency there, more latency there. I mean, if it's a VM running on the same machine, then that's just kind of a container. But I would personally just put it on the same machine. But really doesn't matter. Again, do what works for you. There's no hard or right answer for this. Shay?
Yeah, I mean, setting up a VM is also there's management overhead around that. So is that like a permanent VM that does it get shared between your CI like different CI processes? If that's the case, then again you have to worry about isolation and bottlenecking and so on. And there's really no reason. So I'm just echoing what Arthur said. In general, have your database in the same VM where your tests are running. In general, that would be my default thing. And I would definitely say, just don't bother with local DB necessarily. Think about using Docker, using a container, having SQL Server there. It works perfectly for us in general. It's very stable. You don't have to worry about any flakiness or anything like this. Similarly, in other databases, you have sometimes this question, specifically with Cosmos. Cosmos is obviously something that happens in the cloud, but there's an emulator, so you would run the emulator locally, again, usually via Docker. That's how these things are done nowadays. You just run all your tests against that. That's what we do. It works really well. That's all I have to say about that.
Okay, so the other thing you need to do is seed the test database with data. You often have to put data into the database for many of your tests. And over the years, I should say this is the hardest part to write in a test, right? Because you know what you're testing and you know what you expect the answer to be, but it's setting up all the code. And I was just thinking about this, and this is a guess, but I create extension methods. You could see that in, you see this C database with 4 books. If we go to that, go to implementation. Yeah. So there you are. C database with 4 books, uses create 4 books to create it. And this is quite complicated, but I found what I didn't start with this, but it's I started with something, create dummy book with 1 author, right? And then I thought, oh, I need something more, and then I create, something else, some other books, and these are all ways to create the data that I want to put in my database. And in the end, I came up with this because it's got all the things I need in it, and I used it a lot. So by then I'd worked out what I need to put in here. It's got 2 books with the same author. It's got books with no reviews, some with reviews, all that sort of stuff. So that's the main thing I do. I have these. I call them test helpers, but they're static extension methods, and that's what I use mostly.
I think it's really important when you look at that's the code that's on the screen there. All it's doing is using EF Core to track some entities, and then it's calling save changes to save it into the database. It's not trying to put seed data in the model using the I can't remember what we call it, but data seeding in the model. That's a feature that we added in a few releases ago that I think some of us on the team are now regretting a little bit that we've added it in. It has some value in some scenarios. Generally, testing isn't one of them. And this is a great example of keeping things simple again, right? Like, you don't need a whole lot of stuff like that. You don't need anything more than an extension method like Jon is showing here that adds some data and calls save changes to save it. Remember also, I often see people trying to connect things up by key values when they don't need to. Remember that EF Core works with graphs of objects. So if you give it an author and that author has a list of books, you don't have to save the author first, get the primary key value, set that manually into the foreign key of the book and save those all, right? You just create this graph of things and then just call save changes.
That's why you're using EF Core.
Yeah.
That's what EF Core is for.
Don't make things more complicated than they need be, So and then one last thing on seed data is, I think, as Jon alluded to, you can create a common set of seed data that works for a lot of your scenarios, and that's generally the right thing to do. That is, again, even though it might not seem like it at first, it's again a tension against test isolation. Because whenever you change your seed data, you're changing what's in the database for the other tests are running. And normally, I agree with doing this. It's absolutely fine, and you should do it because it saves work and it makes things generally easier. But I've run into cases in the past where I wrote a specific test that had a specific, entity with only one property in it or something like that to test a specific bug that was not working with that. And then, later on, I've come back to that. I said, I can just add a few more properties and reuse this and everything. And of course, once I've done that, I've actually, without realizing it, broken the test in a sense that I first wrote, because it's no longer testing that scenario. And that's rare. And I'm not saying that you should worry about that. I'm saying you shouldn't generally worry about that. But it is worth noting that as you get a lot of complex seed data, you do have an interaction now between all the tests that use that. It is breaking your isolation.
And that's a great argument. Sorry, go ahead, Jon.
I was just going to say, if you're working on an application which is growing, you've got to be careful with these, because you'll find that something's changed, and you have to change some of your these extension methods because it's something changed, and then you break a whole load of things, and that has happened a lot to me. So just be aware of that. You've got to be thinking about it a little bit. So that's why I start with something simple.
Yeah.
Maybe even just in the class, in the test, and then once I've used it a few times and I'm duplicating it, I make something more, and then I only build this kind of complex thing once I know that's going to be helpful to me.
Mm-hmm.
So,
and I have to say that's another argument in favor of what you were saying before, John, which is creating and seeding for each test, like in isolation. That means that you can also change what you seed, and you can seed exactly what you want for that specific test, because in any case that database doesn't survive and doesn't interfere with any other test, right? So if it does free you from having to think about your seeding data in a global way, this model which you were showing before.
Yeah. So I mostly use that, but I also put unique tests, seeding in the test. And I'm going to give you an example.
Yeah, makes a lot of sense.
So here is this is from my auth permissions library, and I'm testing a whole load of different roles with different types. So here you are, I've got different role types, and I put this within the test, right? So but I've got another one below where I copy that, and I just change the few bits that I want, because this is changed here, and I just keep on going. So that's another good way to work. Within one class, you can just cut and paste and change, cut and paste, change. I would
go ahead, finish. Sorry, I didn't mean to interrupt you. I keep interrupting you.
No, it's all right.
Well, I was just going to say the cut and paste and change is something I wanted to mention as well, because this is something that there are different rules apply, different best practices, I guess, apply when you're writing test code as to when you're writing product code or application code.
Yeah.
And one of the most important ones is, it's okay in tests to have cut and paste and duplicate and then change, because you don't need to think, I don't need to dry, I don't need to make sure that I'm not repeating myself in the test, because as soon as you go down that, if you go down that far enough, you get to the state when I joined Microsoft of the tests where you could never tell what a test was doing, because it had so many different parameters that changed so many things in so many different ways, and then verified all those things again with massive kinds of like differences. And what I really wanted to know when looking at tests is, what is this test testing? What do I expect to happen when it succeeds? What do I expect the outcome to be? And if you copy and paste things, that can be much more clearer in your tests. And so don't be afraid to copy and paste bits of your test code and have duplicated code there, because it really allows you to then go back and use and read and understand those tests much better in the future than if you have you've got, you say, great, I've got 20 lines of code that's testing my entire application, but when a test fails, it takes you 2 hours to figure out what path you took through all of that to get to it. And I've been there, and so I know how painful that is.
Arthur, I'm not sure we practice that all the way in EF core tests.
No, we don't. Again, there's always a balance, right?
Yes,
and then there's people like Andrew who say, no, it's perfectly understandable what's going on.
Yes,
like,
exactly.
I have no idea
understandable is quite subjective, unfortunately.
Yeah.
I will add one more point that came up in the chat. What about template databases? There was a comment there. So that's that. In this context, it's very useful. So we talked about seeding. You can also have a template database, so a pre-existing database that's already seeded. There's various ways of accomplishing that. Jeremy also wrote in the chat at some point that you can even have a Docker image of a pre-seeded database. So your Docker image can already have a database with data in it.
Yeah.
And that can be like your baseline, like John was saying. 70% of common seeding, logic for all my tests, and then 30% of tweaked per test kind of things. That 70%, you can seed it in code, like John was showing here, or you can pre-seed it into your actual database image behind the scenes. It doesn't matter. Like the effect is the same, right? It's another interesting technique, which I personally have never done, but you can do this. And Postgres even has a whole feature. You can have a database that's flagged as a template. And when you're creating a new database, you can point to a template database, and it's just going to copy it across when creating the new database. It's this feature that, now that I think of it, could be very useful for this kind of thing.
I had one project where, and let's see if I can get to it, where I had to had a production database, and I couldn't take it away. It was so I built something which would take that production database, put it into JSON, and then you could put it in. And it's in my library. I took it out at one point, and people said, "No, I'm using that." But that's very rarely I use that, but when you need it, it really works. So you can look at the.
I think the one time that you so the production versus seed data also brings up the question of the amount of data that you have in there, right? When we've done perf sessions, and one of the things that we've talked about, right, is you've got to have a realistic amount of data to actually get perf results. And that's where, if you've got an available production database that you can use to do your perf testing on, that's great. When you're doing most of your functional type testing, you don't actually need that database. And in fact, the Northwind database that Shay talked about that we have in our tests, we've trimmed it down. We don't have all of the data that's in the actual real Northwind database, because that just makes all the queries take longer to run without really giving any extra coverage for anything. So we've trimmed the amount of data down in that, because you're getting the coverage that you need. Again, it's what am I testing? You're making sure you get all the right results, and the query shape and everything is fine, without now having lots of data. Thank you for zooming in. You can tell that I really am in Santorini, because
you switched the fake background to a dark one. How nice!
Switched it, right? Yes.
Very, very.
I want to get with. We're over time. I want to get to the last thing, because this is important, because you can get errors, right? When you let me so this is a little bit hard to understand. So if when you are building a web app and you want to update some data, you get a read, and you show in the browser, and that uses 1 DB context. And when you edit it and send it back, you get a new DB context, right? So that's the normal state. But if you look at this, right, if it's if you have 1 context, it's going to go all the way through. And there are problems if we do that. Let me show you. This is a way to, So this test has got 2 errors, but you can see it passed. It's got, and that is terrible, right? I will show you.
Means the plane's gonna crash.
Yeah, and when this happened once, whoa, So anyway, so. The error is the ad review requires you to I'll show you what you should include the reviews, and that code didn't call save changes, right? And that is bad, isn't it? So there are various ways to do it. You used to do it this way, by creating a unique context for each part, right?
I still do it that way.
Right. I don't like that because it makes it long and I have to type more. There is a fantastic thing that came out in EF Core 5 called Context Change Tracker Clear. I love it. I love it. And
I resisted adding that for so long, and then I added it, and everybody loves it.
I love it.
Because you know why you love it? It's because you're all doing it wrong. No, I'm sorry.
So when this seeded the database, and the context is tracking it, but when I do that, it's not tracking anymore. So then it'll.
So the primary problem here of all of these things, and believe me, this problem is something I see so often when people post GitHub issues like, why isn't this working? Why isn't this giving me the wrong results? It's not doing what I expected. And you know, at a fundamental level, it comes down to the concept of how you use a DB context, which is for a single unit of work. And so typically that means that, you know, you're inserting your data into the database that you're going to use for a test is not the same unit of work when your application is reading that data. And when you're using a web application, it's not the same unit of work as is being used when you then update that data in the request. Those are all fairly obviously three different units of work because they happen at completely different times of the application. And so really, and this is why I say you're doing it wrong, because really, if you're going to follow that pattern completely correctly, what you should do is create a new context for each of those different units of work. From a practical perspective, where this actually catches people out is that once you've tracked some entities, once you've added them to the context and you've called save changes, the context instance is still tracking those, and that's by design because you can continue to use that context for other work and to make changes to them, and they automatically detect those changes. So that's all by design. But if you then use that context as if it were empty and didn't have anything, it's not going to give you the correct results. And this is the first fix that John had here for the include thing. That's why that happens, right? Because even though there was no include in the query, it didn't matter because the context was still tracking the data from before, and so you didn't have to use it. And then, you know, likewise, if you don't actually call save changes, it doesn't matter because the stuff's still in there in the final use of the context. It's still got that change data, so it doesn't matter again. So from a purist perspective, you would create a new context syntax. From a pragmatic perspective, if you don't like typing all of that, what you really need to do is just clear the change tracker out. And that effectively, not completely, but effectively resets the state of the context to a point where you can then use it for your next unit of work without it actually the different parts interacting with each other. And I think it's really important to understand that when you're doing tests with EF.
Yeah, and the last thing then is just in this. There's a link to this article, and it covers that in quite a lot of detail, and why I have to do it. So if you didn't understand it in the video, you can look at that article. And that is everything from me.
Wonderful. We did get to the end. That's good.
Yeah.
I don't know if we have I mean, I've been watching the questions come by, and I think we've answered most things as we've been going through. So, I think we've probably done. Maybe I should just show people some more of the beautiful view of Santorini there. So we're staying in we're staying in a place called Fia Stefani. Hero Stephanie.
I heard the autocorrect in the background.
It's all Greek to me. Yeah. Apparently, they say it's all Chinese to them here. That's what the taxi driver told us. Anyway, I would definitely recommend coming here. It is what you would expect it to be, not a letdown at all. So, I know it's privileged for me to even be here and everything, but thank you, Microsoft, for making that happen. I mean, not that they pay for this trip, but they pay me enough that I can afford to do it. Sorry.
Yeah.
Anyway, so yeah. Anything else before we finish?
Go see our docs on testing in general.
Yes.
Go see the previous community stand-up.
Yes.
Testing is actually not a trivial subject, unfortunately. There's a lot of there's lots of nuances there. It's when you decide on your strategy for testing, read those things and make sure you understand the pros and cons, basically, and don't hesitate to ask us as well, of course.
Yeah.
Yep.
But we won't add relational things to the in-memory provider, however much you ask us to.
That's because we can't. We just
Yes.
can't. There's no way of doing it.
Okay.
All right.
Thanks,
All right.
everyone.
All right. Bye.
Bye.